Here's a recap of how to find the greatest common factor and the least common multiple. Okay, so on the left side we are going to find the greatest common factor of 20 and 32. The simplest way, right, it may not be the fastest, but the least confusing way is just to list out all the factors and then find which one not only they have in common, but is the greatest of them all. Okay, so we would need to list out the factors of 20 and the factors of 32. Now, I highly suggest using the T-chart. Right, the benefit of using the T-chart is for each factor you get, you know by definition there's a corresponding factor that goes with it. Right, a lot of the students will just start listing out from the top of their heads from here, and it's very easy to lose track of the ones towards the end. Right, so by using the T-chart, I ensure that I always get the other side, the other pair of the factors. Right, so 1 times 20 will give me 20. 2 is a factor because I can multiply that by 10. 3 is not a factor. 4 is a factor because I can multiply that by 5. And then I know also a benefit of doing this is I know I got them all, because if I go to 5, then I'll start going backwards. 5, it would be 4, 10 it would be 2. Okay, so then I know I can stop right here, and then I can go ahead and list them out in order to keep it organized. Okay, so do the same thing for 32. Right, now this is where, especially if the numbers start getting bigger past their times table, this is where the divisibility rules will come in handy, because I can use my divisibility rules to quickly determine if a certain number is divisible. So for example, 3, I know it's not divisible, right, even though we're going to assume you don't have your times table memorized past 3 times 10, because the rule says if I add up the digits 3 plus 2, that result, that sum, will have to be divisible by 3 also. When in this case it's not, so it's not divisible by 3. I don't even need to bother to check it. I already know it won't work. Alright, 4, I know it will work because that's on my times table. Okay, 5, right, the last digit needs to be a 5 or a 0, so it won't work. Okay, 6, right, doesn't work. 7, 8, and then once I get to 8, I know I have come full circle. Okay, so those are my factors. Right, now I look for common factors, right, and this is just up to you. They can use check marks, they can circle. Some people like to actually circle both together, right, or you can just go ahead and circle or check marks. It's however way you want to organize that, right, but there's nothing else in common. 4 is the greatest one, so my answer, GCF, equals 4. Okay, now least common multiple is, will pretty much be the same thing, except now I'm going to list out the multiples of each number. Okay, now if we're just finding the multiple, the common multiple, the simplest way would just be to multiply the number by each other, right? But we're trying to find the least, so we need to make sure we get them all. Now in this case, 20, I know if I list them, the last digit will also always be a 0. So I would probably start with 32, because I'm basically going to keep listing until I get a number where the last digit's a 0, and that will probably correspond to a common one over here. Okay, so 32, 64, and this is where if they need to work it out on the side, they will need to do that. So if they can't make this calculation in their head, they'll need to work it out on the side. Alright, 160, I know I can stop, because if I keep listing multiples of 20 here, I will get to 160. Okay, and that would be our least common multiple. Alright, so the listing method is the simplest way, but often, especially if the numbers are a little bigger, right, and then they're definitely going to get numbers even bigger than these on the exam, it could take a while. It can start getting longer and longer. And the factor, maybe not, but the multiples definitely. Right? Because not all this can be done in their heads. They may need to work out each one. Right? 32 times 2, 32 times 3, 4, 5, and all that. Or they can skip count. Either way, it could take a while. So this is where the factor tree comes in. The factor tree, and we're going to review how to use the factor tree in a second, but the factor tree is very beneficial because it breaks the number down into their prime factors, and by doing that we can find the greatest common factor and the least common multiple using those prime factors. Okay, so I'm going to go ahead and do the factor tree of 20 and 32. Okay, alright, and there's a number of ways you can do this. Alright, the simplest way is to see if it's divisible by, if 2 is a factor. If 2 is a factor, I know I can always divide it by 2. Alright, if it's even number, I know I can always divide it by 2, and then pretty much everyone is comfortable dividing a number by 2. Okay, another way, right, is just to see what are the 2 largest factor. Now, by doing that, I will get the same prime factors at the end, but sometimes it's more beneficial to do it this way. Okay, but whichever way they're more comfortable with, that's all that matters. So I'm just going to cross this out so I won't get mixed up. Alright, 32. Okay, same thing. You can break this down into 4 times 8, or just keep it simple. Just keep dividing by 2 since it's an even number. And we can keep on going until we get all prime factors. Okay, so after you use the factor tree, now what do these numbers mean? Well, if we're trying to find the greatest common factor, right, if we're trying to find the GCF, we're looking for common factors between the two. Okay, they each have 1, 2, and this is where, again, it's up to them how they want to organize this. And I like to circle them. Alright, and then I find another one common, circle. Okay, they can use check marks if they want to. I don't suggest crossing out because that interferes with the actual number. Okay, now there's more 2's over here, but because these already correspond to another 2, they're already taken up. You cannot circle that because this one's out of 2. This one has a 5, this one doesn't have a 5, so they have no more factors in common. Okay, so they have a 2 in common and another 2, and you multiply them because, again, factors, you should always think multiplication. That will give me the greatest common factor. Alright, 2 is a common factor, but if I multiply all the prime factors, that will give me the greatest common factor. And you can see that it is the same as what we found earlier. Okay? Alright, so GCF equals 4. Alright, now to find the least common multiple, so using the factor tree, I'm not going to do it again because it's the same factor tree, get the same results, except this time we're trying to find the multiple. Right? And this one's a little trickier. And it's highly suggested that you rewrite the numbers in their prime factor form. So 20 is 2 times 2 times 5. Right? And then we can write 2 times 2 as 2 to the power of 2. Okay? And then, right, we can zoom in a little bit because that's a little small. Okay. And then 32 is 2 times 2 times 2 times 2 times 2, so that's 5 times. Alright, so that means that is 2 to the power of 5. Okay, so we're basically comparing both numbers, look at their prime factor form, and then see what other numbers we can multiply them by so they will be the same eventually. Okay, and now not just any numbers, because that could be an infinite amount of combinations, but we're looking for the least possible one. Okay, which means we want to multiply them by additional numbers as little as possible. Okay, so 20 has a times 5, so it would make sense that 32 also need to be multiplied by 5, or the factors need to be multiplied by 5, then they will be the same. Right? So, because remember, this number is 32, this number is 20, so whatever we multiply by, it's all going to mix up in the end. Okay, so if I multiply by 5, now they each have a times 5. Okay, now 32 has a 2 to the power of 5. 20 only has a 2 to the power of 2, which means it needs to multiply by 2 to the power of 3 to match up with 32's 2 to the power of 5. Right? And then if you want to rewrite all that, 2 to the power of 5 times 5, and you have 2 to the power of 5 times 5. That confirms that they will both be the same, and that would be, right, your least common multiple, and you just gotta find out what that is. Alright, 2 to the power of 5, I already know what that is. That is 32. Alright, so that's 32 times 5, and then 32 times 5 is 160. Okay, so least common multiple is 160, and that is what we have up here also. Okay, and there's another way of looking at this information that might make more sense. Alright, so I'm going to rewrite it. So we had 2 to the power of 2 times 5, and then, and then 2 to the power of 5. It's basically compare, so I'm going to draw a line. Alright, so this is just another way of looking at the information. We got these numbers from the factor tree earlier, okay? Alright, so I'm looking at it and see, okay, they both have 2 as a factor, except this one is being taken to the power of 5, this one's being taken to the power of 2. By taking 2 to the power of 5, that will automatically include 2 to the power of 2. So my least common multiple needs to have 2 to the power of 5, and that will take care of both of these. Okay, because if I multiply 2, if I multiply 2 by itself 5 times, I will automatically include 2 of these. Okay, so I don't need to add additional ones. Right, these have already been included, so by putting down 2 to the power of 5, it includes the one from the 20. Okay, now we need a 20 has a times 5, 32 doesn't have one. Now technically 32 has one, it's just a times 1. And remember, 1 is the same thing as 5 to the 0 power. Okay, so and this 5 really is 5 to the 1 power. Alright, so by multiplying 5 to the 1, 1 obviously already includes the 0. Right, so then this right here is all we need, and that is what we have determined up here. Alright, we just use 2 different thought processes to get to it. Alright, so some may find this less confusing, some will find this less confusing. This one's is usually faster. Right, I mean this one's not that much slower, but it's preference. It's whichever one makes more sense, I would go with that one. Right, if you work that out, you would get 160 again. Okay, and I know this is probably using the factor tree to find the least common multiple could get confusing, so we're going to do another one. Okay, let's see, let's go 15 and then 75. Okay, oops, sorry. Let that focus. Alright, 15 and 75. Okay, so I want to find the least common multiple of the two. So now what I need to do first is find out what the result of the factor tree is. Okay, that's what we get. So 15 equals 3 times 5. 75 equals, oops, sorry, that is not correct. There should be a 3. My bad. Alright, 3 times 5 squared will give me a 75. Alright, so the first method, I will see what is each one missing and what do we need to multiply in addition to eventually get the same number. Right? They both are multiplying by 3, so that's even. They're both multiplying by 5, but this one has additional times 5. So you need to do a times 5 up here. And I usually like to use parentheses just to keep it separate, that we know that this is 15, this is 75. Okay, and by doing that, both sides should be the same. It's 3 times 5 squared. Alright, and that will both equal to 75. Right? If we do the second method, is just to compare. Okay, they both have times 3, so LCM is just 3. They both have times 5, but this one is 5 to the power of 2, so I go with the bigger one. Right? And then that would be my answer, and that would be the same thing as method 1. Okay? And that's probably always going to be faster than just listing the multiples out, even though listing multiples more straightforward. And another disadvantage that listing has is if they make, so going back to the example earlier, if they make any mistake over here, let's say they made a mistake finding the multiple here, so 32 times 3, they got, let's say, 94 instead. And if they're skip counting, they're going to keep on adding 32, then that's going to affect the remaining number. So instead of 128, they're going to get 126 instead. And then they're going to get 158. So which means they will miss this 160, and they're going to just keep on going, and then they're probably not going to find a common multiple. Or if they do, it's going to be further down the line, and it's going to be an incorrect answer. Okay, so that's another disadvantage of just using the listing method, even though it's more simple in terms of the process. But there's a lot more work involved, it takes a lot longer, and there's more potential for messing up. Okay, so it's very useful. I mean, they should know the factor tree already, because we've been doing that since chapter 7 and pretty much all of chapter 8, because pretty much everything we do, we're using the factor tree. We've been using the factor tree, so they should have plenty of practice using that for now. And now it's just a matter of, after they get the factor tree, how do they utilize information? If you're trying to find a factor, right, the greatest common factor, then you're just looking for common factors. Okay? If you're trying to find the least common multiple, then you're going to have to go through this second step here, and that's where they may need more practice. All right?